So today's video is on segment addition and angle addition. And these two things are really important because you see them throughout the year in geometry. So we're going to start really simple, and then we'll talk about some more complex examples. So let me go ahead and just write out segment addition first. So what the basis of segment addition is, it basically is saying that if you take any segment and you break it into two or more, it's called a postulate. Postulate is just a word that means you don't have to prove it. And what it really is saying is if you take any segment and break it into it two or more pieces, all the smaller pieces have to add up to be the entire length of the original segment. So if I take AC and I put B in between, doesn't have to be in the middle, although it could, then we know that A to B plus B to C equals A to C. It is used in just simple solving problems, and you'll also see it when you start doing proofs. You'll see this pop up where you might have this picture as the proof, and this might be on the statement side, and then the segment addition postulate would be on the reason side. So get some real simple examples first. So if I give you segment DF with E in the middle, and I tell you it is 8 from D to E and 6 from E to F, you might assume correctly that the answer is to get DF is just simply adding those two sections together. And you would be correct in that. Now, the one thing you have to be real careful about in any geometry question is they don't always have to give you the same information every time. So I could do another example of the same type of problem. But if I give you different information, you're not going to solve the problem the same way. So in this example, I'm going to tell you the entire line is 20, and this little section here is 7. So there's not going to be here where you're not going to add 20 and 7 like we did before to get 27, because if I tell you the entire length of EG is 20, well, how can this section that is smaller than EG be 27? And it won't. So this section, this is different because remember the theorem says EF plus FG equals the entire thing EG. Well, I gave you EG. And so you're basically solving this. Oh, sorry, that's a 7. You're solving this equation. And so, we know how to solve an equation. We're going to subtract 7 here to make it go away, subtract here. So X will be 13. And you can ask yourself, does this go back and satisfy what I know? I know these two smaller sections, 13 and 7, have to go back and add up to the bigger section. And that is true. 13 plus 7 does give me 20. So anytime in geometry, just be careful about what they tell you so you're solving the problem correctly. Now, certainly they could say it's a midpoint. So I could say, given segment AB, and let's just call it M is the midpoint. And I could tell you that this whole length is, say, 15. And then they might want to know AM. Well, the same reasoning is going to hold true. I need two numbers that add up to give me 15, but those two numbers have to be the same thing. So in this case, you can make an equation if you want. You don't have to, but you could call those two things X. X plus X is 15. 2X is 15. Divide by 2 to get 7.5. Or a lot of people just reason that one out and just know that, hey, if it's broken into two equal sections, I can just take 15 and divide by 2 to get those two equal sections. And by the same reasoning, I could give you 3 sections and say the whole length is 15. Tell me, and all of them are equal. And you could divide 15 by 3 to get 5, 5, and 5. But just remember that that's the basis of this theorem, that every little smaller section has to add up to give you the whole entire section. And you'll see it throughout the year. I'm sure you have seen it. You guys in geometry have seen this one throughout the year. Now, the other thing I want to tell you about this is they can put some algebra. Any of the geometric problems that we have, they could put some algebra. Like I could say x plus 5 is this little section, and this section is 10, and this entire section, let's just put some letters on it, E, F, G is 30. And they could ask you to find x, but you're still using the same concept. This section, which is represented by x plus 5, plus this other section, which is represented by the number 10, has got to equal 30. And we're going to add our like terms and then subtract to get x of 15. So again, the picture is not really drawn to scale there, because if you think about putting 15 back in here, that would make this section 20. So it's a little bit bigger and maybe it doesn't look like that. But you don't want to use the pictures so much as just know how to do the math. All right, so the other thing that is in the same kind of category is angle addition. It's kind of the cousin, if you will, to segment addition. So angle addition says if you have any angle and you have a point in the interior of the angle, if you connect a ray, remember angles are made up of rays. We're going to put some letters on here. We'll just put A, B, D, C. And so as you might expect, because this, now that I've connected this ray, I've broken the bigger angle into two smaller angles. I know that I could add up the top angle, the measure of angle A, B, D. Remember, angles are named by 3 letters, plus the measure of D, B, C, the bottom angle, has to equal the measure of the entire big angle, what we started with, ABC. So a lot of the problems here are going to work much like it did. I always tell my students, if you know how to do segment addition, you know how to do angle addition. So let's look at a couple of examples of that. All right, so what they can do is they can actually just put the angles inside. And we are going to put some letters on here. So let's call this D, E, F, G. And they're going to be asking for, little m means measure. So they're going to be asking for the measure of D, E, F. Well, if you notice, if you trace out, you scoot it up, D, E, F, that's the entire big angle. It's made up of the 2 smaller angles. So we can just write that, the measure of angle DEG plus the measure of angle GEF. Remember, when you're writing these angles out in 3 letters, the vertex has to go in the middle. It's got to equal the measure of angle DEF, what we're trying to find out. So we can simply just substitute in DEG is 10, and GEF, the bottom angle, is 40. So our answer is the addition of those 2. And just like when we talked about segment addition, angle addition can work 2 ways. So I can give you the almost same type of scenario. I can make an interior ray that breaks this big angle into 2 angles. But now I can tell you that ABC is 60. So that means the entire big angle is 60. And I can say the measure of, let's see, let's put a letter here. Let's just put a D. DBC is 20. And of course, I'm going to be wanting to know, I gave you DBC, which is the bottom angle. So I'm going to be wanting to find out ABD. And so in this case, because I was given the big angle it's going to work out like we did with segment addition. If we know the big angle, we're going to need to subtract to get that top angle of 40. Now, the only other thing that you have to think about here is just like before when I talked about the segments having a midpoint, we can have what we call an angle bisector. So I can take an angle, and when I put the line, I'm going to try to draw this as close as I can to the middle. So I can draw a ray that's coming through the middle, and they'll use the word bisector. So what's going to be a little bit different, let's just say B, they're going to tell you that ray BE is a bisector. All right. So again, they're going to give you some information. I'm just going to give you the measure of angle DBF is 50 degrees. And I want to know the measure of angle DBE. So think carefully about what this is saying. And trace out the letters if you need to. DEF is here. Oh, sorry, I wrote that wrong. That's DBE. No, sorry, DB. Let me just start over with that one. So what I want to be 50 is DBF. Let me just erase all that. Sorry. DBF. So DBF is 50, and I want to know the measure of EBF. So again, trace out what you're given, DBF, and what you're wanting to know, EBF. So they gave me the whole entire big angle, and I want to know the smaller angle. And thinking about what I know about a bisector cuts it in half. So if you take 50 divided by 2, we know our answer is 25. And not only would the bottom angle we're talking about be 25, but the top angle would be 25 also. All right, and one other way this problem could work, again, I could give you another angle bisector problem. See if I can do this one without messing it up. All right, and I could say measure of angle ACK equals 23. And I want the measure of angle KCL. Well, again, you have to be careful about what information they're giving you and what information they're looking for. So ACK is 23. That means 23 is this top angle. And KCL, trace it out, KCL is this bottom angle. So that's going to be the same thing because an angle bisector cuts the bigger angle into 2 equal parts. But what I was talking about being careful is if this was a multiple choice question, they would also have 23 divided by 2 as one of the answers. They would have 23 plus 23 as one of the answers because maybe they were going to think you're going to get confused and think they're asking for ACL. So you really have to, when you go into any test that's multiple choice, it doesn't always mean that that's easier because they're going to put all those distractor answers, and you really have to know what you're doing. You have to know how to name these angles and trace them out, think about what they're giving you, and answer the correct question. So a pretty easy concept overall, these two things, angle addition and segment addition. But just make sure you've looked them over and you've studied how you name angles, how do you name segments, and make sure you know the angle addition postulate and the segment addition postulate also for your proofs, because that's going to be something you'll see later. Okay, guys, y'all have a good day.